Hello, Internet. I've had a heck of a time recording this video. Audio issues, um, and other things. Well, let's give it another go. I've been making a game. It's this game, Capture the Flag. So it's Poppyseed Pets Capture the Flag, and it was occurring to me, I don't know how much I've talked about Poppyseed Pets on, in these videos. Probably most people watching know, but just in case, it's a free virtual pet game set on an island filled with magic and strange technologies. It's a browser-based game, right? We're in a browser. It's pretty minimally graphical. It's pretty graphically minimal. Yeah, I almost said it right. Um, you've got items. Oh, it works good on a phone. It's actually really meant to, it's mobile first. So yeah, check it out on your phone. You can pin it to your start screen. It'll ask you to do that. It's a progressive web app. There's a bunch of stuff going on. But anyway, it's this game that I've been running for a very long time. Um, and I've also wanted to make a Capture the Flag game for a very long time. First, the audio issues were with hardware. Now the audio issues are, I guess humans are considered wetware. It's kind of a gross term. But anyway, apparently I can't talk. But we're going to make this freaking video. Um, I'm combining two things I love, is what I was trying to say. I have played Capture the Flag in real life as a little kid, and then I bought a DOS game in middle school, which I will show you, that I based this game on. And then I played in college because I convinced my college friends. I mean, I don't think convince is quite the right word. We were all, happy to hang out and run around like idiots on campus at like 10 p.m. or whatever. And occasionally have security complain at us, only occasionally. But yeah, I freaking love Capture the Flag, and of course I love Popseed Pets. Popseed Pets has been around since 2019, but really its predecessor, Sci Pets, which I also ran, I started in 2004 in college, and it had Capture the Flag inside of it, but it was something your pets played. This is something you play. And I guess I should mention it's a standalone game. That's probably obvious, right? This is a desktop game. It's going to be sold on Steam. That's how the multiplayer is going to work. I'll talk about some of the technical stuff of the multiplayer in a little bit. Um, yeah, completely standalone game. It'll be on Steam. You don't have to play the web game to play this game or vice versa. But before I show you this game, I want to show you the game it's based on, the one I alluded to that I bought in middle school, and I still have the copy that I bought in middle school. It, of course, cannot be played on modern computers without an emulator. It's so funny to me, I don't know, having grown up on PCs, that I need a DOS emulator because I think it was Windows 98, I think, still ran on DOS. Like your computer started up, it started DOS, and then from DOS you launched Windows. But it was kind of like, I mean, you could opt to not do that, right? I think that was true up to 98, or maybe 98 was the first time that wasn't true. But anyway, it was true for a long time, so it's very funny to me. It's like, what do you mean I need a DOS emulator? This runs on. It's like, no, it doesn't. That's not been true for like 2 decades or more. So anyway, let's go find Cap Flag. I'm going to show you the demo. So there's this Cap Flag 2 executable, which also the word execute for my first recording, kind of a funny word we use in computers. But I don't want to show you that because it has my address in middle school. I don't know, but it's right there on like the cover, not cover art, like the title screen of the game. Um, and I don't know. I can't dox myself in the past, but I don't know. It still feels weird, so let's not do it. Um, but we're not going to care about that. We're going to care about this wacky art. What has happened to this poor man's body? Don't worry, the art in the game looks better than this. I mean, actually, that's kind of funny to say. It is better than this. It's funny that you can be limited to 16 colors, and that's not the problem. The problem is what you did with them. And like I'm not complaining. I mean, right? I love this freaking game. I bought it. I have the legal copy, full copy. I reached out to this guy, in fact, and was like, "Please re-release your game on Steam. This is like a game from my childhood, and I want to share it with everyone." Um, I'm just gonna have to do that by making it myself. So here's what the graphics look like in game, right? They're not as bad as what we just witnessed. Here are all my characters. I've got them all, starting from Aaron through Heather, I guess. Right, we're looking for the enemy flag. It's a turn-based, tile-based tactical game. Um, and I don't know. I love that. I love those kinds of games. So you run around. You may have noticed something interesting happened. So we've got different stats, right? This person has like medium vision, very bad stealth, pretty good movement, and excellent agility, which is good for both capturing people in your territory or avoiding capture. But something has happened here where, I've got trees in my way. That person maybe has excellent stealth. They're standing on a tree. Standing is harder to see than running. Running also you don't see as well. So there's a lot of different factors that go into can you see the unit on that tile? And they're saying no, you know that someone's there. Well, you know that's the last person the last place you saw that person. It could be that after they take their turn, oops, no, I want to do that. I want to keep moving. Um, it could be that after the computer takes their turn, I mean, it's almost certainly the case that that character is going to run off somewhere else. I'll have no idea, but that's the last place that I knew them to be, right? So they're giving me that question mark block. And as we run, you can see these, right? The black spaces are being revealed. And now I'm out of movement points. And they're going to say, would you like to change your stance? And I'll say yes. And if you watch the mini map, you'll be able to see it better. But we're going to get a better view because when we stand, we can see further. So yeah, wow, he saw way further. Or I guess that was Heather. No, that was Ed. And right, we're trying to find the enemy flag. So that's it. You can try to capture people if they're on your side. I mean, you've played Capture the Flag, right, in real life? I don't know. Because it's a demo, he only has this one map for the demo. That's part of the restrictions of the demo. Another restriction is you can't do prison game mode where you capture someone and then they have to walk to prison and then someone from your team has to sneak up and tag you while you're in prison to release you. In the full game, he has that, and he has a map editor that you can use to make your own maps. I think we can probably see that too. I don't know if that's. Let's not do all that. Cancel. Do you think you can still call his phone number and order the game? 20 minutes from now. That's interesting. How it can be emailed to you. Okay, using America Online. Interesting. I mean, in my mind, probably just for me, like I did not have the internet when I was playing this game. Like we mailed this dude a check, right? Like I probably just had to be like, Mom, here's the $20. Please, will you write this guy a check so I can get the game? So I didn't get it in 20 minutes. Well, there's a map editor as well. Isn't it called Map Edit? I don't know. Or it's DIR. Show me only the executables. Map Build. Anyway, because I have the full version, I have a map builder, and I've made my own map. But the map builder is like, it's a pain in the ass to use. Anyway, this isn't what I'm here to show you, but he's got a map editor. But it is related, so I didn't want to deal with making a bunch of maps. Making an editor just takes more time. Maybe I'll do that sometime. I don't know. Maybe that's like an add-on or something for the game later. A big update, everyone. Because again, this will be on Steam, right? Version 2.0, it has a map editor. I don't know. But what I've decided to do, because even with all the maps you get when you pay for the game, you run out eventually, and some of them aren't very, very interesting, blah, blah, blah. So I was like, no, I'm not doing that. I want to randomly generate them. So I've made, so far, 5 different map types, and it arranges them differently. So now let's look at the forest trail. And this, I just tried to use that game's controls. In that game, you right-click to pull up the mini-map. In my game, we've got more screen space, right? We have wonderful widescreen 16:9. And by the way, this can run full screen. I haven't set up the keyboard shortcut or whatever for it. But anyway, it can run full screen, right? 16:9. His game was 4:3, so he just didn't have as much space, left to right to fit things. But it's the future, and we have those things now. So anyway, you can just have the mini-map all the time. So here's my flag, here's my little units, and other important detail, right? My units are the Poppy Pets units. I've mostly reproduced his stats. 2 things about his stats. The whole thing with the positioning, like, do you want to stand up or do you want to run or crawl or walk? Those were the 4 stances in his game. I felt like, A, it's another thing you have to learn, and B, it's a thing you have to learn for very little payoff. Like, it's a whole system. There's all these things of like, okay, running is the worst for seeing, but the best for movement. And then crawling, you also don't see well. And it's really bad for movement, but you're also really stealthy. Like, I don't know, just like, it's not that hard to internalize because you know how walking and running and looking and crawling work in real life. But it just felt like this other system you had to learn for a system that you use very rarely. My experience with the game was you run, and your turn stand. Next turn, run, stand at the end so you can see far. Maybe you would stand in between to get a good view before deciding where to go next. And then at the end of the game, when you were close to the enemy flag, you would do more crawling because you want to sneak up and not be easily seen. But it takes up such a small percent of the game, yet is this like thing the game is always bugging you about, like what stance do you want to be in, blah blah blah. And it's like, anyway, so I've decided I'm simplifying. I'm getting rid of that mechanic, and I've got some ideas for what to do instead. Something else as a difference from poppy seed pets. In poppy seed pets, all these species have the same stats. There's like 100 whatever of them. Where are they? 111 of them. Here's this amalgam, which we can see up here is right here, right? This head. So these species, I've recreated several of them in the game. But I wanted to give them different stats, and I wanted to use different species since I was going to make it poppy seed pets themed. Another thing I don't like about the original game is that even though on both sides you have the same team composition, you can't really tell by looking at another person, another unit, well, what are their stats? I like that in this game, right? I can look here and say, if I see one of these guys running into my territory, I know he's really fast and he can see far. I also know he's really bad at avoiding capture. And by the way, because I got rid of stances, I got rid of stealth as a stat, and I've split up attacking and avoiding capture into 2 different stats for my game. So I've done some tweaks here. So anyway, oh my God, yeah, I'm going to be able to capture this guy. Or if this guy was used to defend, you're going to be like, yeah, but like he can't capture, right? Like if I had him defending the flag, that would probably be a bad idea. Well, maybe he can see really far. That can be useful for defending the flag. But anyway, they've got different strengths and weaknesses, which was true in the original game, but also, I think importantly, you can tell what you're up against when you see another character, you know what they're capable of. And in theory, you can know in the original game, but everyone just looks like a human. They all look like the exact same human, and it's difficult to line up. Like there's some key you can use to see what their name is, but they don't just show you the enemy's stats. So it's, I don't know, like in theory you have the information, but in practice you don't really use it because it's too annoying to get to, right? That's not an ideal situation. If the information is there, you should have it. That's also a thing that kind of bugs me about games where card counting is a skill. I think just for me, I don't like games where, in theory, the information is there. Like, yes, you have it, but it's really hard to access. I don't know. That doesn't work for me in a game. Like, if the information is there, then just let me see it. Then I want the information. So I'm not as fond of games like that. If it's something like hidden movement, that's really interesting. Sometimes you have those asynchronous board games where, I don't know, someone is doing things in secret, but you can piece together and clue, and then it's interesting, right? Then it's a puzzle. It's not like you should know. You've got to figure it out. Anyway, sorry, a whole other topic. So yeah, I don't know. I don't think I showed you the computer turns. I'll take my turn. This guy just kind of floats. All the graphics, I know what's happening. I was noticing that the clicking was a little off. Somehow my guys are slightly off the tile. It's probably because it's to do, so I just recently added animations for like hopping. So like this guy's gonna hop, 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 hop through the ground. But what I'm noticing is that like he does not properly fit within the space. And I was noticing something was off recently on like clicking on them. So I'm gonna fix something. Something weird happened. But anyway, they run around, they see into the woods. We don't have the different stances, like you can't stand to see further, but whatever. This guy just gets to see farther all the time. His vision is incredible, whereas this guy is, I mean, he's medium vision and he's also in a thick forest. I think this guy has, yeah, like horrible vision, is also very slow, so he's not, yeah, gonna get to do much. So anyway, it's the same game. Yeah, we can, I don't know, we can watch the computer take their turn. I don't think I showed that in the other game. Something I'm debating right now, so you can notice there's a long pause here, which so I've been going back and forth on when so every time the computer moves, there's a little artificial delay so that you can, we want to be able to let you see the move as a player. But if you, like right now, someone's moving, but it's not clear who, it's someone in the darkness. Anyway, I just want to change the timing so that if someone isn't seen, it doesn't delay the game. But also, if someone has just lost your vision, I do want to delay, because something that was happening before, I used to have no delay when units weren't visible and they were moving. But then what would happen is like someone would jump into the dark, and then suddenly the camera would zip somewhere else before you barely processed, oh, that guy went in there. Where did he even go? Too late, the camera's zipping off to the next unit who you can see moving. So I just need to, be a little smarter about where I'm putting the delays for you to watch what the computer is up to. So anyway, there's a lot going on here, but there's 2 things that I want to talk about if we want to start getting technical, which I guess is what I do in these videos. So, as I mentioned, his game, I didn't have internet access. I, physically mailed a check and got a copy back. And for multiplayer, you could play locally. He had that as a feature. So the way that it works to play locally is, you're both on one computer. So one person takes their turn, and then when they're done, says, "I'm done," and I can show you how it works here. I mean, I'm doing basically the same thing. Yeah. So you say, "I'm done with my turn," end the turn, and it says, "Okay, now it's the next player's turn. So I need to leave the computer, summon my friend back over. They come here and hit the button, and now it's their turn." And he has an option where you can put in a password in case you don't want to, I don't know, if you don't trust your friend. You should probably trust your friend, but he has a password option as well. I haven't added a way to quit games early, so I'm just going to have to restart the whole program. I'll add that before putting this on Steam, which that's the other thing we have in the future. We have Steam. So for him to play multiplayer remotely, he had play by email. So the idea was you would take your turn and then it would say, "Great, your turn is over. Here's the save file." Email that save file to your friend and they'll pick it up. And then the password system is probably more useful there. It's available on both, but I don't know, the other person can't take their turn on their computer and then, just to look at your units or something and send back the game, like, because you have to enter the password to take your turn. You get to pick your passwords at the start during your first turn. So anyway, we don't have to do that now. We have the future. We have Steam, and Steam will. They give some server capabilities to connect players up to talk on the internet. And I thought I would draw some pictures about that. Again, I already did this like twice before, but I kept having various audio issues. But this will be the one. So you probably know that you have an IP address. I think everyone, I don't know, maybe I shouldn't assume this, but I think a lot of people are aware of IP addresses in general. You can go to Google and say, "What is my IP?" and it will tell you an IP address. I think people were more familiar with IP addresses in the early days of like, oh, I just stopped having a dial-up modem and now I have my little home network. And I feel like people were more setting up their own home networks and you had to know some stuff and you would call support and they'd tell you to type commands to reset your IP address. I don't know. I don't know how much, as a programmer, as someone who has to think about IP addresses, it's really hard for me to know, like, how much does the average person know about an IP address still today? I don't know. But anyway, I'm going to draw my computer. Here's my lovely computer. That's a weird computer. Let's make it I don't know, here. That's what a computer classically looks like. It's a monitor on top of a box. There's my computer. It has a disk drive. Wonderful. There's my computer. And you may have seen this IP address. Maybe you think it's funny that I know your IP address. I don't know your IP address. Everyone on their home network these days has this IP address. The purpose of an IP address is to be an identifier that you can use to communicate with other people, on the network, on your network, on the internet. So how does this work if multiple people have the same IP address? And this is true. You're at home, this block, this 192.168, there's another, it's 10. I forget, 0, 10.1? For some reason, I think it's 10.0, but then for some other reason that feels unlikely, but I bet it's 10.0. Anyway, there's a couple IP addresses that are commonly used for home networks, and that's because everything on the internet that talks on the internet has agreed that these are kind of like special ranges of IP addresses for this purpose. But it does mean that it's utterly useless for talking to someone else on the internet, right? Every home network is going to have 192.168.1.1 through 255 in some distribution used. These do not uniquely identify. So how does that work? How can we possibly send messages to each other? Well, you have a little modem sitting somewhere. I don't know. I'm going to draw your modem with some little antennas here. Here's its antenna. Right? This is whatever your ISP sent you. And when it talks to you, it's going to talk as like 192.168.1.1. You usually do .1 for that first thing it's not required, but usually the first thing is going to be a .1. And then typically you're starting around .100. Maybe on your network, you just start at 50 or I don't know, some arbitrary distance away from 1. But then when it talks on the internet, when you go to Google and you say, "Google, what is my IP?" what you're actually getting is this thing's IP address, because your modem is the thing that's actually talking on the internet. And it's going to be, I don't know. I'm just going to make up something. It's going to be, I don't know what it is. And so the communication happens like this, right? Your computer is talking to your modem is talking to the internet. Here's the internet. And then on the other side, a similar thing is happening, right? There's probably better tools for doing this, but I'm going to use Paint. Someone else has their thing, and their thing has a different unique IP address. And these IP addresses are sold to your ISP. Your ISP buys some block of these. There's a couple organizations that handle this stuff. So to ensure that these people have unique IP addresses, right, whatever they are. And if it's the same IP, or sorry, if you have the same ISP, right, if you're both using whatever, Comcast, Xfinity, aren't those the same? Who are the other people? CenturyLink, whatever. You probably have similar first couple, but then there might be some variations in here, whatever. There's going to be some other IP address. And this one again on kind of on the inside of its network has this 192.168 1.1. These things aren't fitting anymore. What have I done? But whatever, you get the point, right? These two things talk to each other, and they've got their own little bubble where they're talking with these IP addresses. You've got your own little bubble, you're talking on these IP addresses, and then everyone on the internet, whoops, I've changed it. Everyone on the internet is talking with these more, these public unique IP addresses. If you heard about IPv6, there was a little worry people were having of running out of IP addresses. So we've done this clever thing so we can reuse a bunch of IP addresses over here and over here. But there's only so many of these IP addresses that we can all have just straight up on the internet. And as more and more things want to be straight up on the internet, we're using up these IP addresses. This is why we need to have other organizations, we all agree. It's like, you're not going to reuse, right? You bought this range of IP addresses. You get to use them. Don't use ones that you weren't assigned, or you're going to cause problems on the internet. So it won't just sell these IP addresses to anyone. You can't just go and buy an IP address as an individual. They're not going to trust you, whatever. For good or bad, you have to go through an ISP. But this creates another problem. Why am I talking about all this shit? I've made a multiplayer game. You want to host a game online, and you want someone else to find you online. IP address would be the way to do it. I mean, you don't have a domain name, right? Your computer isn't www.benshomepc.com. You don't have that. Even if you did, it would be okay. You would figure a thing out. Anyway, you don't have that. You've got IP addresses. This is how computers talk. I could make a whole other video about, I don't know, TCP/IP and all these other things. So how do we solve this problem? Well, the way you solve it is Steam exists today, or some other service. Some other service like Steam has their own computers on the internet. And Steam says, look, we're taking a cut of your game. When you sell on our platform, we take some % cut. And in exchange, we give you a bunch of stuff. We give you this platform where people are going to find your game, or they're going to buy your game. And we also give you servers with some limited capabilities. You couldn't make an MMO with the servers that we're going to give you, but you can do a lobby to facilitate some conversation. So you're going to say, I'm running Capture the Flag. Let's go out to a Steam thing. And I'm going to say, hey, Steam, I want to make a little game lobby. And Steam is going to say, great, you have your little game lobby. And then when someone else wants to join, they're going to come and say, great, I'm talking to Steam. Steam, I know what lobby I'm looking for. Can you hook me up? And it's going to say, yes, you are now here too in this lobby. And now you will communicate through this third party. And Steam has a bunch of its own IP addresses. Oops, I'm still in green, but whatever, right? That your computer knows how to find. There's other things, right? Again, domain names like www.myhomecomputer.com, right? There's domain names that you reach out to, and those can, whatever. So you say steam.com, give me something, and they say, sure, we've got a computer here, go use that one. It's got some space for your lobby, whatever. So this is how the communication works. One of the things that Steam gives that is great, because if Steam didn't give me this and I wanted to do this multiplayer, there's a couple options. So the classic option from the olden times, in early internet, you did have an immediate IP address. And actually, there's other things you can still do today. You can tell your modem if you've got access to it. Most ISPs don't let you have access, but you can go in here and say, hey, look, if anyone comes calling on this IP address and they're looking for Capture the Flag, actually redirect them here. So you can set up these little bridges to get through. So you could still do, if you're willing to go into your modem and router settings and configure that shit, you could do a direct line and not go through, I mean, you'd still be going through the internet, but you wouldn't have to go through Steam. You could configure that. And only one of you has to do that, because your computer can say, I want to reach out to this IP address knows to sneakily forward. And then when it responds, your router is doing that all the time, right? When you go to google.com doesn't have to get to your IP address. Your router has tracked, you asked for something from google.com got back to me, I know that's for you, you can have it back. So only one person has to do this fun configuration over here. Anyway, most people aren't going to do that. I know how to do that because I'm a silly programmer who grew up with this stuff, but most people aren't going to know how to go into the router and set that shit up. So you do this, right? You go through Steam, or the other thing I could do if I didn't have Steam would be that I would go to, Amazon cloud computing, Microsoft Cloud, one of these cloud providers, and I would say, I want to pay you for a little server and I'm going to install my own little lobby running thing, right? But that costs money, and then I would have to make lobby software. Steam says you can have it for free. We took a cut of every sale of your game, so and we've already made the lobby. So all you have to know is how to talk to our lobbies, and hey, PS, we're going to give you the code to do that because we want you to use our service. So it's one of the ways that Steam A gets people, because they say, hey, look, you don't have to make a lobby, we made it for you. Hey, look, you don't have to pay for it. And hey, look, once you're on our platform, wouldn't it suck to leave? Because then you'll lose this cool lobby feature we gave you for free. So it's beneficial for Steam, but it's also beneficial for me. I don't want to pay Amazon and Microsoft to have a server forever. The other thing that Steam can do, another reason they can offer this, they can offer this for my game forever, for as long as Steam lives, because in reality, capture the flag, not many people are going to play, and for any game, it doesn't matter. Most people aren't going to play it for very long, right? There are some of these games that are crazy successful and people play for a long time, but most games, they come and they go, and people stop buying it and people stop playing it, and Steam says, we don't care. We've got plenty of these things for all the other games. You stop using our free resource. Great. That's what we wanted, right? Whereas if I ran my server, I would have to have it online all the time for just me and decide myself when is it the time to cut it off. And then I have to tell everyone, sorry, there's no longer the online feature available, right? There's a lot of overhead in managing that kind of thing that it's great for me to not have to worry about. So that's one thing I wanted to talk about. I'm looking at how long this video is, and it's been 25 minutes, 26 minutes. But there is another thing I wanted to talk about. I wanted to talk about the enemy AI. So let's end the turn again and watch these computer players run around, right? How are these things running around? How are they deciding what to do? One thing that I talk to people about sometimes, and they're confused when is like, how the computer obviously just cheats all, right? It knows everything, right? They know where my flag is. So why don't they all just rush my flag, right? How do you make the, what? Turn wasn't over. Okay, now it's my turn, right? How do you make the computer, in one sense, it has access to all the information. So how do you kind of give it that information in a way that makes it a fair game, right? Like, I don't know. And I've had some people like almost like, I feel like I'm being accused of like something or something of like how does this work, right? The computer is cheating. And like, yes and no. I mean, computer games cheat in a lot of ways. One thing I don't think people appreciate, a lot of games cheat in the player's favor. So, I mean, a famous example, I probably mentioned this in a previous video, but there are a lot of games, like shooty gun games, which I don't know, whatever. I'm trying to think, whatever. Why am I saying? My brain now is in like old 90s, early 2000s times, so like Unreal Tournament, which is what I played back there. What's it called? Call of Duty, right? These are modern games. A lot of these games, when you first run into a room and there's a bunch of enemies and they shoot, they are programmed to miss intentionally the first few times to give the player, a chance to be like, oh shit, I'm under fire. Take cover, we cheat in both directions, and we just cheat to make the best gameplay experience possible. We, as developers, right, making these games are cheating to make the game as good of an experience for the player as possible. And there's a lot of things that go into that. It should feel fair. Yes, the computer could be perfect and have perfect aim and just headshot you all the time, but no one wants that. So we fudge all these things in various ways. Something else, though, that's important is to have the computer behave in a way that you like kind of understand. Also, I'm noticing now that my, again, they're not lined up. Sorry, I just saw it again. It was distracting me. We want the computer to behave in a way where you look at it and go like, oh yeah, that makes sense, right? It's acting as if it doesn't know these things, blah, blah, blah. And it is in some senses, we've got some tools in this game to help us achieve that. So one of them is, we're obviously tracking what spaces each unit can see. So even though the computer at any moment can say, where's the enemy flag, right? The computer can just know, where's my flag. We also, though, as developers, know what tiles you have revealed, right? I have seen this one in the past, but I can't see it now. I can see these things right now. So there's some tools here. So anyway, let's talk about the next thing. So this is, speaking of old games like Unreal Tournament, there is an old AI technique called a state machine. And there's some states here, but let's do another artist rendition using our favorite tool, MS Paint, apparently. Um, not colored pencils and paper this time. I needed to show you graphics, so I didn't draw this stuff on paper. Yes, there's a fun way I can switch between screen capture and camera, but that sounded like a pain, so we're not doing it. So let's draw some like circles to represent different states. And these are going to be different kind of modes that the computer is acting in. So, and we, as the developer, I get to decide what are these going to be. Well, I want them to be things, again, that a human will kind of understand the behavior of. If you see it happening, you're like, okay, I get what they're doing, right? It makes sense from a human. So what are the things that a human might do? Well, you might be, searching for the enemy flag. That is a thing that you might be doing. So that is a state that we will allow the AI to be in, which again, I'll talk more about later. Another thing to do is you might be, once you know where the enemy flag is, you're going to be like, okay, I'm now capturing the enemy flag. That is my new goal. Another thing you might want to do is you might want to defend your own flag. Something else I decided that I would want enemies to do is to patrol own territory, right? Looking for enemies. Right? Looking for enemies that I can capture in my territory. That's another state. And then another thing that we might want to do is we want to capture an enemy, right? An enemy in my territory. So, right, I mean, capture the flag. You can't capture people when you're in the opponent's side of the field. It's only in your side. So we have these states, and we can program up these states, and I'll go through one of them later. But the thing that makes it a state machine is that you have conditions by which you transition between these states. And state machines get used in tons of stuff in computer science for like matching text. If you want to know, like, is this text that someone gave me, does it represent an IP address or an email address or other things you can use? They're abstracted away, regular expressions, blah, blah, blah. They use state machines under the hood, blah, blah, blah. Let's not talk about that. But another thing that you can use them for is computer AI. So you say, great, we're searching for the enemy flag, but there will be a point at which we say, we're no longer interested in doing that. We want to switch to capturing the enemy flag state. So that would be because now I know where the enemy flag is. Or while you're defending your own flag, you might spot an enemy nearby and you say, great, I'm going to switch into capturing an enemy. That is my new state. Same for when you're patrolling. You might do the same thing here. My arrows are get too close, right? These are some transitions that can happen during the game. And it would be common to have ways, if the game was more interested or more interesting, more complex, more real time, there would be more opportunities for things to go back the other direction. Since this is turn-based and you pretty much are like doing your one thing, in particular, when you capture an enemy, your turn is over. That says, fine, you've used all your movement points. You can't do anything else. So once you're in this state, you either failed to capture the enemy, got as close as you could but couldn't or whatever, or you did it, in which case, by these games rules, your movement points are done, so you're done. You're not taking anything else, not doing anything else in the turn. But the start of your turn, everyone moves back kind of implicitly to their original state. But it's kind of funky. I don't know. It's not working in the true sense of, I don't know how you might, I mean, it is and it isn't. And let's just draw these arrows. So this would be, it's the next turn, you move back to your original state. That's something that would happen. Except for people capturing the enemy flag. Once you know where the enemy flag is, there's no point to keep searching. You're going for the enemy flag. You might say that as a human player, maybe you would be interested in like scoping out alternative routes. Like, would it be better, there's like random forests. Maybe the way that you found the flag goes through a bunch of forests, and as a human, you might be interested in finding a faster route. For the computer, I'm not going to bother with that. That is something I could code. I mean, and that's an advantage I have, right? I could, and a power of the state machine thing is I can come up with more states. Any state that I find that might be useful to help the computer play more intelligently, and again, in a way that a human can look and kind of understand, oh, I get what they're doing, or it feels smart, or whatever. I can just make more, and as long as I have sensible connections between these things, it's a powerful system. I mean, something else I'm not doing, I drew these lines to connect these different things. Right now, these two things never touch in a way. Never do I have the computer go from defending your own flag to trying to capture the enemy flag. But in principle, I could do that. I could say, you know what? here's the condition. If you know where the enemy flag is and there's no one nearby and you feel confident about that, you don't see anyone in your territory, you think everyone's accounted for, maybe you should stop defending your own flag and just go rush the enemy flag. Maybe now's the time. I could add that, right, as another transition between states to give more intelligent feeling to these AI controlled things. But I haven't done that. Maybe I will, maybe I won't. I don't know. But yeah, this is a very popular way of doing AI. I remember when I was, again, in college, a game had come out, and I was looking into this before this video because I was trying to remember what the game was. I thought it was Halo, the first Halo, because I remember people were going nuts over how cool the enemy AI was in Halo. But I did a little Googling, and I think it was actually the game Fear. But what I remember at that time was people were saying, oh my gosh, they'd have a state machine. Like even non-programmers, right? Just gamers were very aware of this AI is smart because it's using like states. It was this goal-oriented, whatever. And it was part of like the marketing push of this game was to talk about this, about how smart their AI was because they had goals and it was a state machine. And so people were talking about this. So yeah, it's an old technique. It's been around since, the early 2000s and before. Again, many uses besides AI. It's just a super cool tool for solving many kinds of problems. And happens to be very useful for computer AI as well. So having said all that, let's look at a particular implementation. I alluded how the word execute is kind of a funny thing we say in computer science. I don't know why. When you execute something, that means you run it, not that you murder it or kill it. I don't know why, honestly, but anyway, it is that way. So I say that each of these game states you can execute. And actually, let's look for seeking the enemy flag. That one's probably a little more straightforward. So yeah, here's the seeking the enemy flag state. Here is the function that kind of contains the whole, like all the logic for it, right? This is what we do when we are in that seeking the enemy state. This is how we execute that plan. We carry it out. There's some little stuff up here. Don't worry about that. Let's look at this part. So this is just, while some condition is true, we're going to keep doing the stuff inside. The curly braces, by the way, are like the start and end of some block of logic, right? This is here's how you execute the seeking enemy game state. It is wrapped inside this part. Here is just everything about the enemy game state, right? It's got multiple parts. So we use these curly braces in C-style languages. They're called C-style because the first, probably, I don't know, was it the very first? I don't know. One of the first, the very influential one that did it first was the programming language called C, and now many languages have copied that style. This language is called C#. It's got C in the name, but JavaScript also uses curly braces. Many languages do. Many also don't. But the ones that do are C style for the most part. I'm sure you could use curly braces and not be C style for other reasons, but whatever. I'm getting off topic. So anyway, while these conditions are true, we're going to keep doing this logic inside. So the conditions are you have to have movement points, right? Whoever this team member is, they need to have movement points greater than 0. They need to have any movement points left. And I just have this kind of sanity check. Thanks, Windows, for letting me know. To make sure that the game isn't over. I do that for all of them. It shouldn't ever happen when you're seeking the enemy flag. It would only be when you're actually charging the enemy flag, right? When you know where it is and you've actually captured it. Like, you're not going to accidentally capture the flag without meaning to in this game state. But just in case, I was like, let's check. Let's make sure the game hasn't been won. And if it has, for whatever reason, we'll just stop. Again, I don't think it should happen, but I'll check. So what do? First, we pick a new exploration target. What does that mean? I'm finding unexplored enemy tiles. I say positions because you get a list of positions, but basically I'm looking at the map, and again, we know each team has that kind of, those black squares of what's been explored and what hasn't. So I'm looking for the closest, in this case 10, spaces that haven't been explored, and I just pick one at random. Here's what this part does. If we found any, then we're going to pick one at random. We should never, this is another thing, it's like we should always find one, because, I mean, think about it this way. If you have seen every spot on the map, you will never be looking for the enemy flag because you'll have found the enemy flag. So you should never be here and have no unexplored spaces left. But again, I don't know. I have to do something down here at some point, like, because I'm checking, well, did you find one? Maybe you didn't. I don't know. This function might return nothing for who knows what reason. I don't know. So I have to check. So I say, okay, if we found them, then I want to pick one. Otherwise, what I'm going to do is, I don't know, there's these things called exceptions in code. But I'm going to say this should be unreachable. This is an unreachable exception. This code should never be reached. If it is reached, something truly bananas has happened that, it's a bug, or I don't know, what is it? Sometimes cosmic rays hit your computer memory and do something weird. Whatever, right? This should never happen. But I need to account for it for other reasons. I've assured my, you'll see a squiggly red underline. I have assured the programming language that this function returns a position. So if I can't return a position, I have to do something. So I'm saying, look, it's a crazy fucking error, and we need to bail. But anyway, I've probably talked about it longer than was important. So the first thing we do is we pick a position. Then we move to it. There's a lot hidden in here. How do you find the fastest path to a point? You can't just go in a straight line. You might go through a bunch of trees. It might be easier to go slightly around. I'm using the A-star algorithm. That's a very popular algorithm. You can Google a bajillion million implementations. I found one, and I tweaked it to account for like trees are harder to move through than other things. But it's a general pathfinding algorithm. So there's a lot behind this. That could be a whole other video, but the point is we find some path. And again, this path is going to be of some length. It could be that for whatever reason, maybe this logic was kind of silly and I picked an unexplored. So from this function's point of view, I say find a path to some position. Here's my current position. Here's where I want to go. And then here's a bunch of game data about the map, so it can find those things. What if these 2 points are the same? Like they never should be, but this function itself doesn't know that they shouldn't. It doesn't know what came before. It just says, look, you gave me 2 points and I found you a path. What if, so it could return no path. It could say, yeah, I got the path. It's this very cell you're on. The very one cell you're on, you did it. Congratulations, you're there. So it's possible that it only returns one space. Again, I'm pretty sure it shouldn't because I asked for a faraway path, but what if there's a bug here that made it not do that? So anyway, I want to just account for that. Make sure that it found a path, and if it doesn't, then we're getting out of here. With a next state of no state is what this ends up doing, but we won't talk about that. But anyway, the point is we're checking, right? I think just a general thing in programming, it's called defensive programming. You hope that your code works as expected, but it might not. And what you really want to do is treat each of these as an independent piece and say, some data went in, some data is coming out, and I want to account for all the possible kinds of data, all the possible outputs. And it could be that we get a length of nothing, of go nowhere. We don't think that should happen, but we don't know that there's not a bug up here. We don't know that there's not a bug up here. We don't know that there's not a bug up here, right? Any of the things that led up to this point, there could have been bugs that make this not behave the way we want. So we check that everything makes sense. That's going to happen again. So anyway, once we find this path, assuming we found a path that has some length, then we just, for each step in the path, we follow it. So we get a direction from my position to the next position in the path. This is kind of whatever. We're going through each step in the path, getting the new direction. And again, this should give us a cardinal direction. It should give us north, northeast, east. I guess those aren't, or whatever. We get the diagonals as well. We shouldn't ever get a none. Again, if everything is behaving properly, we shouldn't get a none. But I don't know, this function returns a direction. What if it gives us a direction of none? Then we shouldn't proceed because it's not going to work. So again, we're just going to exit out. We're going to say return, we're done, get out of here, get out of this execute method. We don't know what happened. It should never happen, but we don't want it to proceed and maybe crash the program instead. This will crash the program, by the way. This, when you throw an exception, that's going to crash. I'm so convinced that this will never happen that I'm willing to let it crash. This, I'm like, it should never happen. But rather than crash, let's just make the AI stop moving. Like it's a bug and people would see it happen. They'd see the AI like take a step and then stop for no reason. It's possible that you just think it has some strategy that it doesn't have, right? A human watching the game doesn't know that this is the logic. So they might just think, oh, that's interesting. Is it defending, right? You might ascribe some meaning that wasn't there. But also it's probably better than crashing the game to just have the AI do something a little stupid. Arguably, I should do something down here, but like, I am so sure that this will never happen. I want to be super alerted if it does. Like, I want my game to crash in front of my eyes and tell me that that happened, because this should never happen. But anyway, for this thing, again, I'm feeling a little differently. It's like, it should never happen, but let's just let things keep going. Then we take our movement, and then we handle the result of the movement. So when you ask a team member to move, some things can happen. They make sure they, like, did you try to move off the edge of the map? Again, our pathfinding should never have told someone to move off the edge of the map, but this function for moving team members, it doesn't know what told it to move. It could have been your keyboard press. It doesn't know. So it's handling any possible, situation. It doesn't know who asked the unit to move. It doesn't know why. It just knows that it got a direction. So it says, great, I need to check everything. Did you try to go off the map? If so, I'm going to tell you that you went off the map. Do you not have enough movement points? Then I'm going to tell you, you don't even have enough movement points. Were you blocked by an enemy? Are you in friendly territory and there's an enemy there and you ought to be capturing them? Well, then I'm going to tell you there's an enemy that you bumped. And then for the human player, that will prompt a dialogue to pop up to do whatever. And then for an AI, they'll handle it differently. So anyway, all these little things happen for the computer to move. It updates the revealed tiles, right? We get the whole team to see the new tiles for after that move, blah, 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 blah. And then, again, what we were talking about, what are we talking about? We're talking about a state machine. How do we transition between states? And this is the important part. And here's where some of the funny, like, yes, the computer knows everything, but we use it in a way that, kind of makes sense intuitively to players that doesn't feel like cheating. So we ask my team from the point of view of the AI. So the AI bot is like, hey, my team, all of its tiles that have been revealed, find the one to do with the enemy flag position. This probably looks like absolute garbage nonsense. I promised you that programmers think this is reasonable. There's other ways to do this, but yes, this is a very reasonable approach to index into this array. But anyway, we look up the flag positions, right? In this moment, the AI grabs the enemy flag position. It knows exactly where it is, but then it uses that to say, well, if I look at my revealed tiles, and I look at the tiles for that flag position, is it there, right? Have I revealed that flag position? Another way we could do this is we could go through all of the revealed tiles and say, does this one have the flag? Does this one have the flag? Does this one have the flag? And that would be maybe more of a like intuitive human way of like, look at the tiles I can see, look at them and see if there's a flag in any of them. But instead we're doing the reverse of saying, we know all the tiles that you saw, just see where the flag is and see if it's in there. So it's a more direct way to get there, but in a funny, I think there's just an interesting case of like the AI is using its knowledge of the enemy flag position, but your flag position, but in a way to act like, it's doing the thing that a human would do, to be more efficient. Because to do it the other way would be less efficient, right? So anyway, and then if this condition is met after we've moved, then we're going to change states. We're going to get out of this state's execute function. We're going to say, nope, we want a new state. It's the charging the enemy flag state. That's the new thing to do. And then it will pick up from there, which has its own logic. And that is, I know where the enemy flag is. Just compute me a position from me to the enemy flag position, and then let's just go. And it just goes. And again, using the pathfinding to navigate around obstacles and things. And here's where I decided, I was like, if for some reason you absolutely totally bombed to fail a path, like that should never, I don't even know that this makes sense. I could even see throwing an exception. It was like, I don't know, I guess go back to seeking the enemy flag. But honestly, that might just put the code in an infinite loop. So yeah, it's possible. I mean, maybe you just need to not move anymore. That's probably a better thing. But again, this should never happen. This should never fail to find a path. So whatever. Unless, yeah, if I've coded things properly. So anyway, I don't know. That's it. I mean, there's the other states. They've got their other logic. But that is, I don't know, hopefully gives a sense of how do you code some AI, and then also how does networking happen. Also, this video is 48 minutes. What? I'm sorry, this was way too long. It was shorter on previous recordings. I thought, well, at least I'll be able to summarize a little more, quickly, having done this twice before and failing because of hardware issues. But now it's like 50 minutes. That's ridiculous. Well, if you watched this far, then I guess it was interesting, or you would have clicked away a long time ago, but I'll say it anyway. I hope this was interesting. I will be back with some other technical video, hopefully longer than, in a shorter amount of time than it was between the last two videos. Again, I just like my failure to record this didn't all happen in one day. It was like I failed and was like, I'm gonna go do something else, and I tried twice, and I was like, God, I'll do this later, right? So that just delayed me making a video. But hopefully it won't take so long next time. I did finish reading. Why am I blanking on everything? Sailor Moon. I finished reading Sailor Moon, so I could talk about that. I really don't know what else I would add other than that, yeah, it's Saturday morning cartoon style level plot and an interesting look at the 90s. Which maybe is a good summary of this game too. It's capture the flag. That's a pretty simple plot. And we got an interesting look at the 90s. So wow, there was more time than I even expected. That wasn't, I never made it this far before because I kept having issues, like the cat unplugging my microphone in the middle of recording. Anyway, thank you very much for watching, and goodbye.